Welcome everyone. We are discussing second order derivative. Today I will discuss if an expression y is given, then how to find proof of general expression. For example, so look, problem number 1, y equals to a sin log x b cos log x. So obviously base is 1. You have to prove x square y2 xy1 plus y equals to 0. An expression is given, you have to prove another expression. So what is dy by dx? A cos log x, then derivative of log x is 1 by x. B into minus sin log x into 1 by x. This is first order derivative. Now we can find also second order derivative, then putting value of the first order, second order and y in LHS of the expression, you can prove this result. But this will be lengthy. We want to prove direct result. So look, to avoid cosine rule, you have to multiply x on both sides. So x dy dx equals to a cos log x minus b sin log x. So for it and given expression as 1. So these are both problems or maximum problem of Wbjee. Differentiating both sides. W3x. So x into d2y dx2 plus dy by dx minus a sin log x into 1 by x minus b cos log x into 1 by x. So differentiation of a cos log x and b sin log x. Now look, x is again at the limit. So you multiply both sides by x. X square d2y dx2 x dy dx equals to minus a sin log x plus b cos log x. Now this is by relation number 1 y. So this is minus 1. Now write the result according to answer. So double derivative is represented by y2. This is y1 and this y is transferred to the left side. So y is given, you find dy dx, double derivative, then you can put the value to left hand side and you may get proof. But this will be lengthy. Our main aim will be to get direct proof. So to avoid cosine rule, we are multiplying it again, you get direct result. Next, problem number 2. Y equals to e to the power tan inverse x. These are all problem of both. So what is dy dx? E to the power tan inverse x into 1 by 1 plus x square. Now to avoid cosine rule, 1 plus x square into dy dx equals to e to the power tan inverse x is equals to y, and it is obtained from 1. So it is very simple to differentiate y. Derivative is dy dx. Next, differentiating both sides with respect to x. So 1 plus x square unchanged, d2y by dx2 plus 2x into dy dx derivative of 1 plus x square, and this one is dy. Now look at the proof. So final result is 1 plus, according to problem this is y cubed, and dy dx common, this is 2x minus 1. So this is d2y dx. Then 1 plus x square into y plus 2x minus 1 into dy dx equals to 0. So you get direct result. Now problem number 3, y equals to sin inverse x whole square. Now call it 1. What is dy dx? 2 sin inverse x into 1 by 1 plus into 1 by root under 1 minus x square. 2 come forward, derivative of sin inverse. Now to avoid quotient rule, same technique. Root over 1 minus x square into dy dx equals to 2 sin inverse x. Now you can differentiate it directly, or to avoid square root, you may take square of it. So 1 minus x square into dy dx whole square equals to 4 sin inverse x whole square. What is sin inverse x whole square? This is y. So call it 2. To avoid root over, we can take square on both sides. Now differentiating both sides with respect to x. So 1 minus x square unchanged. Derivative of dy dx whole square, 2 dy dx into d2y dx. Why? 2 come forward and power diminished by 1, then derivative of dy dx is d2y dx plus minus 2x into dy by dx whole square and 4, this is dy dx. Now mind it, if you take square on both sides, then 2 dy dx will be cancelled on both sides. So let us verify. 1 minus x square into d2y dx. So this one is 2 dy dx minus x into dy dx multiplied by 2 dy dx. So 4 dy dx. So 2 dy dx will be cancelled on both sides. So what we are getting in the list final step, it will be 2 dy dx will be cancelled out. And write the result according to answer. 1 minus x square into y2 minus x by 1 minus 2. So you are getting. Now, or listen, this is one process, or you can differentiate it. So, or you can differentiate it. 1 minus x square into d2y dx 2, and derivative of this is half 1 minus x square whole to the power minus half into minus 2x equals to 2y root under 1 minus x square. So multiply both sides by root over 1 minus x square. 1 minus x square into d2y dx 2, and 2 cancel. This is only minus x by 1. So this will be cancelled out. X. So x into dy dx unchanged. Obviously dy dx unchanged. So x into dy dx equals to. So you differentiate it by product rule, then you also get the result. Next, so suppose problem number 5. X equals to 1 by a log y. Look here, in all cases, y is a function of x. So in this case, x is expressed in terms of y. So try to express this in terms of x. So 1 by a log y equals to sine inverse x. So sine transferred to right hand side. So log y equals to a sine inverse x. So call it 1. Now it will be simple. Whenever you are getting sine inverse x, you always get 1 minus x square into y2 minus xy1. This is common. This one is common. This one also common. So differentiating both sides. 1 by y dy dx equals to a into root over 1 minus x square. So root over 1 minus x square into dy dx equals to ay. So I have already stated, you may take square on both sides or you can differentiate. So if you take square on both sides, 1 minus x square into dy dx whole square equals to a square plus. So differentiating with respect to x. Now by Buddha rule, 1 minus x square unchanged, this is 2 dy dx into dy dx. Mind it, dy dx whole square, derivative is 2 dy dx into this. Then dy dx whole square unchanged into minus 2x. So this is a square 2y dy. I have already stated that if you take square on both sides, then 2 dy dx will be cancelled out. Look here, 2 dy dx, 2 dy dx, 2 dy dx. So we are getting with 1 minus x square into d2y dx2 minus x dy dx equals to a square. So this is the flow. Or you can differentiate it by product. If you take square on both sides, you get direct. Next, problem number 4. Y equals to, in all cases results are same, sine m sine inverse x. If m is not present, this will be x. Due to presence of m, you cannot simplify it. So this is our 1. So dy dx cos m sine inverse x into derivative of m sine inverse x is this one. So avoid quotient rule, cos m sine inverse x. So taking square on both sides, taking square 1 minus x square to avoid root over dy dx whole square, m square cos square m sine inverse x. Now m square, this is 1 minus sine square m sine inverse x. Now m square into 1 minus y square, this is 2 from 1. These to be noted. Y equals to sine m sine inverse x. So sine m sine inverse x, then whole square. So this is 1 minus y square. Now differentiate it by product. Differentiating both sides, Wrtx. So 1 minus x square unchanged, 2 dy dx, mind it, into d2y dx2 minus 2x into dy dx whole square. So m square unchanged minus 2y into dy dx. Now we are taking square on both sides. So you have to cancel 2 dy dx on both sides. This implies 1 minus x square into d2y dx2 minus x dy dx equals to minus m square y minus m square y. So this will be plus m square y equals to 0. So correct it. So 1 minus x square into y2 minus xy1 plus m square y equals to 0. Now y is given. So these are most important problem for both. Y is given and we are finding an expression involving y2, y1 and y. So write problem number 6. Y equals to log x plus root over x square plus a square. Prove that x square plus a square into y2 plus xy1 equals to 0. So this is 1. So what is dy dx? Function is log. So 1 by x into root under. And you have differentiated many times. Derivative of x is 1. X square plus a square will become minus r into x. So then try to simplify it. X by root over x square plus a square. Then x plus this one unchanged root over x square plus a square unchanged plus x. So this and this is cancel out, x square plus a square. So we are getting dy dx in this form. Now to avoid quotient rule, x square plus a square into dy dx equals to 1, and squaring both sides, dy dx whole square equals to 1. So call it 2. Call it 2. Differentiating again with respect to x. So x square plus a square unchanged, 2 dy dx into d2y equals 2 plus 2x into dy dx whole square equals to derivative of 1 each. Now you know, if you take square on both sides, then 2 dy dx will be cancelled out. So x square plus a square into d2y dx2 plus x dy dx equals to 0. So this is our answer. So write y, make first derivative, make it simplified form. Avoid quotient rule. If there is root over, take square. Or you can take derivative of it. Then try to get direct. So today, through this video, we have learned if y is given, how to find an expression involving y2, y1 and y directly. So you practiced some problems like this from any standard. So thank you for today.